Let's face it, that introductory to computer class was challenging in 9th grade. With everything becoming more and more digital, it can be overwhelming. And sorry to break it to you, this is just the beginning. Did you know that 92% of the dollar is digital today? And with this new technology called the blockchain, it's only a matter of time until all forms of purchasing become digital. But before you try to call my bluff or try to form any opinions, let me explain what the blockchain is and how it's one of the biggest innovations in the last 50 years. By the end of this video, you'll have an understanding of how the blockchain works, what problems it can be solved, and how it can be used. Still interested? Cool. In 1981, a group of researchers needed a way to timestamp documents so people couldn't backdate them or tamper with the documents themselves. Kinda like a notary. However, this technology went mostly unused up into the year of 2009, when a little white paper popped up titled Bitcoin by an author named Satoshi Nakamoto. This paper implemented the technology created by the researchers in 1981. The technology was a chain of ledgers. Each box represented an open ledger that was completely open to anyone. What makes these box ledgers so special is once data is recorded, it becomes extremely difficult to change the information within the box.
Whoa, Terrence, slow down.
Okay, let me explain more. Each block in the blockchain holds data. The hash of the current block and the hash of the previous block before it. The data that is stored inside the actual block depends on the type of blockchain. Yes, there's different types of blockchains, but for this video, we will refer to Bitcoin. The data in the blocks of Bitcoin's blockchain contain a sender, a receiver, and the amount of coins. Each block has its own unique hash.
Okay, dude, you're losing me. What's a hash?
A hash is like a fingerprint. It identifies a specific block, all of its content, and is always unique. Once a block is created, its hash is then calculated. If you change something inside of a block, its hash will change too, making hashes extremely useful if you want to determine whether or not a block has been tampered with or been changed. In other words, if the block changes, its fingerprint changes too. The third element inside a block is the hash of the previous block, which creates a chain of blocks, thus making the blockchain extremely secure. Let me show you an example. Here is a physical representation of the blockchain with 3 blocks. Each block has a hash and the hash of the previous block. Block 3 is pointing to block 2 and block 2 is pointing to block 1. And for those of you that are watching and are like,
Hey, yo, Terrence, what about the first block in the blockchain and its previous block?
well, that block is special. So special, in fact, it has its own name called the Genesis block. This block is the only block on the blockchain that has no previous hash. But back to our graph. Let's say you decide to change block 2. This will cause the block of the hash to change as well, making every block after it invalid.
But, yo, Terrence, can't you just change all the blocks after it and make their hashes line up?
Good point, but let me introduce you to a little something called proof of work. This is a mechanism that slows down the creation of new blocks. Bitcoin, for example, takes 10 minutes to create a new block. This is done intentionally, so if you tamper with one block, you'd need to go back through and tamper with the proof of work for all of the following blocks. So, what makes a blockchain extremely special is its creative use of hashes and proof-of-work mechanics, along with one other mechanism, how the blocks get distributed. Instead of using a central authority to manage the blocks, like a government or bank, the blockchain uses an open peer-to-peer network that anyone can join. When an individual joins the network, they get a full copy of the entire blockchain.
But Terrence, what happens when a new block is created?
When a new block is created, it is then sent to everyone on the network. Each node verifies to make sure that the block hasn't been tampered with. And if each node verifies and it all adds up, then the block is then added to the blockchain and all of the nodes receive that new block. All of the blocks are called consensus, and they work together to figure out which blocks have been tampered with and which blocks have not. Blocks that are tampered with will be rejected by the other nodes in the network.
But Terrence, what happens if the blockchain gets hacked or something?
Hacking the blockchain is practically impossible, and I'll explain why. In order to hack the blockchain, you would have to tamper with all of the blocks on the chain, redo the proof of work for each block, and take control of over 50% of the peer-to-peer network. The blockchain is a digital technology that keeps systems fair, free, and holds all that participate accountable. Today, the technology is used on things like digital IDs, data sharing, digital voting, real estate transfers, medical records, and even tax regulation. Hope this video gave you a better understanding of the blockchain and how it's revolutionizing the digital space of the internet. If you have any questions, feel free to comment below and I'll do my best to answer them. Until next time, peace.